We're going to get into the multiple angles, the double angle formulas, and the product of sums, and half angle ones. This is a lot like what we did yesterday and the day before, where you're kind of just looking at the problem and substituting into a formula on your formula sheet itself. So a lot of this stuff shouldn't be all that complicated, shall we say, because it's just substitution and knowing how to work with the formulas. All right. I believe 5.5 takes a couple of days to go through. I think I only have like 3 examples for today, and I think another 3 for Monday. There was a change on the homework stuff. On the day 2 stuff for 5.5, please add in numbers 41 and 45. For the day 2 stuff of 5.5, add in numbers 41 and 45. It's kind of funny how we give you examples of all this stuff, but we didn't assign any of the problems of the type that you should go do. 41 and 45 for day 2, yeah. That'll just be, we'll start with that stuff out. So just putting some more problems on. What do you think you just forgot to go through? So let's see here. As far as the rest of it goes, if you're looking at your laminated sheet, you're going to get these what are called double angle formulas. The double angle formulas is when you have like 2 times theta, 2 times like sine of 2 theta, something along those lines. And if you look on here, where is the double? The double angles are on. It says double angle relations. It says stuff like this: sine of 2x is 2 sine x cosine. Oops.
Where is it?
Okay.
Right.
So the only difference between this formula and what's given to your book is they use an x, not a u. Also, one thing you will notice is that when they're talking about the cosine of a double angle, you get cosine squared minus sine squared. That's all they write on this sheet. But remember, using Pythagorean identities, if you use Pythagorean identities that sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared, that's how you're able to manipulate between those other 2 forms of that function. I would write those down because sometimes it's a little shortcut that helps you simplify things out, especially if you have multiple parts going on at the same time. I know it's not on the laminated sheet, so it might be something I throw in my notes, or if the fact that I make sure that on my note card, and I make sure that I always write out Pythagorean identities. Okay. Does that make sense? So what I want to do is kind of show you guys how this works, how you use the formula in a problem, and I don't think it's going to be horribly scary bad. At least I hope. Do what? No what? You gonna say something? That you hate me?
We don't hate you, we just don't like you.
It's fine. Feelings mutual. And you know it. All right, let me show you an example. 2 cosine x plus sine of 2x equals 0. On my formula sheet, first one I have is sine of 2x is 2 sine x cosine x. So what I'm going to do is just rewrite that second part of the equation as that. The double angle here, I'm just going to use substitution. And I get 2 cosine x plus 2 sine x cosine x equals 0. And now you're at a relatively straightforward problem to solve. I use the formula. The sine of 2x is a double angle. Double angle tells me I can break it into 2 sine x, cosine x.
I
Okay.
don't like
That's how it just breaks it apart. It's kind of like when we did some of the trig identity things, when you simplify verify, where you break things apart into easier things to work with. It's kind of the same basic idea. Where we had problems back, what was it? 2 cosine squared x plus a cosine squared, plus cosine x equals sine squared of x. When we had something like that before, we had to rewrite everything in terms of cosines to solve it. It's the same basic principle, but yet we have what's called a double angle formula, instead of just saying that this is 1 minus cosine squared and moving it back over here. That's all. It's just another way to manipulate an equation.
So that's just all you
No, we're just starting. So you have 2 separate terms. What do they have in common? Bulk it out, factor it out, focus it out. Do I have 2 separate terms set equal to 0 then?
Wait.
Yeah. And you set both equal to 0 in software.
Why is it only one sentence? Oh, okay. What?
There's only one. See how this one has 2 cosines, this one has a 2 and a cosine? If I factor it out, that's all I'm left with. In the idea wise, it's the same thing as this. What do they have in common?
Okay.
So I factor out a 2z, I'm left with 1 plus 2. Or excuse me, 1 plus x.
Alright.
It just so happens I have more letters, that's all.
You're having problems with
Story of my life. So you have 2 terms, multiplying together, set equal to 0. Set both terms equal to 0. 2 cosine x and equals 0. 1 plus sine x equals 0.
You sound like in the movies, like when the guys are trying to like serenade like the girl.
Oh yeah, because I'm a great singer.
But like they don't know how to sing, so it's like funny. Ever seen that in the movie? It happens.
She has to say anything moment every once in a while.
It's more like all the time. Alright.
That was from a movie, Say Anything.
Oh.
John Cusack. Well, he wasn't singing, he held dead. So again, go back to here, you have what angle has a cosine value of 0, and what angle has a sine value of -1. What angle gives you a cosine value of 0?
5. And 3 pi over 2.
So pi over 2, 3 pi over 2. What angle gives you sine value of -1?
3 pi over
3 pi over 2. Now, did this problem start out with, what do you call it? Like a within 1 revolution or anything like that? No, so that means we have a general solution there. So what we're looking at here, you've got your general solution since you have this one, these 2 repeat off of one another.
So it just be plus pi.
This one would be a pi over 2 plus pi n. And this one would be a 2 pi. Now, actually, to be honest with you, you could probably get away with this being the most generalized because no matter what, if you have to, well, you have to list them both because if I just pick the pi over 2, that means that pi over 2, it would be a solution for this. But is it? No. That's why I gotta be careful when I look those through. Since they're not shared between both of them. Does that make sense? What? What? This? No, this is right. I'm saying that I can't just say 3 pi over 2 is pi over 2 plus a pi, right? But if I just say that as my only answer, that means that the pi over 2 part is a solution for this, where it's not. That's what I'm getting. Yeah. That's all. So that's how you solve that through. Pretty silly. Hey! Long time no see, and no, I don't get any popcorn.
It's been a long time. No, I don't know.
Oh.
Dustin Mars.
Mr. Lars.
You've been a real long time. Dang.
Our children must be well behaved.
Well, you must have been very. You had a very good class.
No. You guys owe him money or something, or does he owe you money?
Can buy my
There you
discount
go.
cards.
All right.
I know it's a problem.
This is another one you guys will see. Evaluating using double angles.
What?
Given terminal sides of theta within a specific quadrant, whatnot. See you guys, have a good weekend.
Yeah, it really does.
Yes, sir.
It feels like a Monday.
It's the Thursdays, it's those half day Thursdays, so.
Especially like my life.
Nobody would come to school. No, we're teachers. You think we're productive?
Like, doesn't that just throw it? Can it give you more height Thursday?
You know what? It's not bad because even for us, but as math department, for me, it's really easy to make a lesson or do a quiz or something like that that's only going to be 28 minutes long. That's easy to do because you can do half a section. You can do something like that without a problem. Whereas some of the other things, if you get into, it might be a little bit more difficult to talk up, to do a lab, and you need more time, things like that. So it doesn't matter to us. So what we're going to do here is we're given the cosine of theta is 5/13, and we're going to place it into quadrant 4. So what we want to do is there's my cosine value. We okay with that? What's my opposite? If I place theta at the origin, cosine is 5/13 placed in quadrant 4. What's my opposite?
Second.
Triple. Well, is it positive or negative? Negative. It's negative 12 for my opposite. Okay. So if they want, what they're asking you to do is find the sine of twice theta. We use the formula. Sine of a double angle is 2 times the sine of theta, cosine of theta. Well, the sine of theta in this case is what?
12, negative 12 over 13.
Good. So this is 2 times negative 12 over 13. And what's the cosine?
5 over 13.
Times 5 over 13. So, what's 13 squared?
169.
What's 2 times 5?
10.
What's 10 times negative 12?
Negative 120.
There you go. I don't remember if that simplifies off the top of my head. That's not. And I do the exact same thing with cosine double angle. So the formula for cosine, move this up a little bit. See, the cosine double angle,
Is cosine
cosine squared x minus sine squared x. Or, what were the other ones?
sine squared.
Or I can do cosine squared.
1 month.
That was the other one, wasn't it?
Yeah. So you can pick which one you want to use.
Which one do you think would be the easiest?
Cosine squared.
Yeah. Yeah. That's it.
So
So now you just take your value of cosine. Was that a 2? Yeah, put it. We missed a 2 there. Oh, it is a 2 cosine, excuse me. It was 2 here. So now it's just 2 Our cosine value was, what? Was 5 over 13? So the 2 times 5 over 13 squared minus 1. So what's 5 squared? 13 squared. So I get 5 squared over 13 squared is 25 over 169. If I multiply 2 times 25, I get 50. So right now I have 50 over 169 minus a whole number. Well, what's that whole number with the common denominator? Oops. Let's subtract. 119. 169. The calculator does all that for you.
So we're able to use our calculator?
Yeah.
How
The
much?
fraction stuff.
Because most of the tests you should do.
What's that?
Most of the tests you do.
Yeah, you really don't, but I don't think at this point now, I don't know if it's gonna help you with anything.
Yeah, because
Some of the-
ones that you can't run for.
Right, and some of the fraction things are pretty easy to, I mean, you can do the fraction ones, but other than that, I think there's anything else the calculator can help you do, that's correct. Yes, ma'am?
Why was the 2 distributed to 5 but not to 13?
Because it's two of them.
It is 2 over 1. Okay. And the last one was the tangent double angle. And tangent double angle was 2 times the tangent of theta over 1 minus the tangent squared of theta. Well, if I go back to my triangle, or did I give you that one? In the book. So you can do a couple of different ways. Tangent was negative 12 over 15. I can do that.
Wait, is that a 15 on the bottom? Yeah, shouldn't it be 13?
Oh, it's supposed to be 5, negative 12 over 5. I don't know why I wrote 15, I'm sorry. It's negative 12 over 5.
Come on, Mercury.
I'm sorry, I read it wrong. I was looking. Now, that's one way to go about doing that. All right, that's one way of doing it. So the numerator here, I'm going to get negative 24 over 5. Down here, I'm going to have 1 minus 144 over 25.
Yeah. So you got to
You can, or you can probably figure it out.
probably not.
Yes. 1 as a common denominator would be 25 over 25. Are we okay with that?
Yeah.
25 subtract 144 is going to be
90.
119, negative 119.
Yeah.
So this is negative 24 over 5 divided by negative 119 over 25. Multiplied by a reciprocal. Oops, I'm wrong. Negative, it's be 120 over 119. Take a look at what we already have. Don't I already have a 120 and a 119? What's negative divided by negative? Yeah. The little shortcut I was about to show you here is if you already found the sine and the cosine, isn't tangent sine divided by cosine? So would tangent double angle be sine double angle divided by cosine double angle? Yeah, John.
Let's go down a little bit.
At least said
See, if we go back looking at what we had the sine of the double angle wound up being negative 120 over 169. The cosine of the double angle was negative 119 over 169. The tangent of our double angle wound up at, bless you, 120 over 119.
I think you were saying. Oh, sorry, I didn't. For what?
How dare you?
What I'm saying here is that
Appreciate it.
if you have to find all three of them, just take the sine divided by the cosine. It's quicker than trying to redo the whole thing with tangent, because you're going to get the same
And
answer.
then we still get all the points.
Because tangent,
What if it says like show your work?
then show your work.
Then you just show.
If you show that you're doing this, it works. Because watch what happens. If you take negative 120 over 169 divided by negative 119 over 169, you get negative 120 over negative 119, which becomes positive, and you're done. That's all. If you have to find just the specific tangent, yeah, go through the formula. But if you don't, remember, the little shortcut thing is that if you've already found the sine and the cosine, just reuse them. Okay, just reuse them. It's a nice little shortcut. So maybe off to the side say, hey, tangent of a double angle is the sine of a double angle divided by the cosine of a double angle. It's a nice thing to have just in case, you know, if you don't have to go through the whole process of substituting in that 1 minus tangent squared and doing all the other stuff, you don't need to. Okay? Does that make sense why I'm saying it like that?
Yeah.
It just shortcuts it. That's all. It's just a nice little shortcut. And I know obviously it's not on that formula sheet, but be something worthwhile. I know we're not doing power reducing, so we don't have to worry about that. But let's look at these half-angled ones. The other set of formula ones are also on your sheet. They're called half angles. It's when theta or x is just divided by 2, hence half an angle. Convenient how that works. These formulas look nasty, but they're right here for you, so you don't have to memorize them. You just have to know that you use them when you have half an angle.
Where are they on this?
On the right,
Right below.
right below the double one.
Um,
The reason that this one gives you a cotangent one because this is a college one. So you might use it when you go to college if you take the class or whatever.
yeah, probably not.
I honestly don't remember it. So yeah, if you're working with the half angles, it's just a matter of using the formulas again. You got your plus minuses, things like that. Obviously, tangent's a little bit weird, but that's what it is. Excuse me. Let me show you an example how it works. Use a half angle to find the exact value of the sine of 105. Use a half angle to figure out the sine of 105. Well, if your theta value is going to be 105, 105 is half of what angle?
210.
210. So if I'm looking at, that means I'm going to use 210 as my theta, as my value of x then. So half angle says where sine of x over 2 is going to be where our x's are 210. Okay. 210 drops to the third quadrant, and it has what as a reference angle? How far is 210 off the
Oh, 30.
30? It's 30. So we start playing around with that. We know that you're in the third quadrant. You have a 30-degree reference angle. Is cosine positive or negative in the third quadrant? Negative. Okay. So I'm looking at doing, well, 1 minus the cosine of 30, or actually of 210. So in there, we know it's going to be a negative value. Cosine of 30 is what? Well, draw your triangle. Root 3 over 2. Okay. It's going to be negative because I know it's something that that quadrant. So we write it out as square root of 1 minus, well, the negative root 3 over 2. And this is all being divided by 2. Okay. So far, so good? So it just looks really weird because you're going to have two radicals. You wind up with, let me move this up again. We have 1 plus root 3 over 2 all over 2 for right now. So to get a common denominator in here, for that numerator part, it's going to be a 2. Are we okay with that? So you write it out as 2 plus root 3 over 2. Wait, did I write that backwards? No, all over 2. And it's a big square root. So you get a double root. It just looks nasty. Okay. If you want to leave it there, that's okay. You don't have to worry about it. Because if I ask for a decimal equivalent, there's, in the grand scheme, do you need to go all the way down to the most minute part? What's that? Well, if you go to any STEM field, you're going to use all this stuff. And the only last little bit here, yes, sir.
Why is it over 2? Just like, should it be?
When you do the,
I'm confused because of the root 3 over 2 and all of
you get that in the numerator,
okay.
and then you're dividing that by 2. So you times it by a half. So if you bring this back out, you wind up with over 4. And think that you can drop them through as things simplify through. That's why they just leave it. You know, you just leave it. It's not a big deal. The only other thing I was going to say is that when we started this out, you have this plus minus piece. And this is where you come back at the very end, whether you know if it's going to be a positive or a negative value. Well, the plus or minus value depends upon where does the original angle lie. Well, the original angle was the sine of 105. Sine of 105 is in the second quadrant, correct? Is sine positive or negative in the second quadrant? Positive, so my answer is positive. If it was negative, it would have been a negative answer. That's why there's that plus minus value. This sine depends on where the original angle lies with its trig function. That's the only rule. And I think it's written in the note on that one. The sines of the half angle for sine or cosine depends on whatever quadrant that angle lies in. Right? That's all it is. Very, very easy to work with. Okay. Plus, you can always check into your calculator to see if you got a positive or negative answer. You can type it in. I think I have one more for the half angle. Well, cut that off. We're going to solve an equation on the interval 0 to 2 pi. So when you see interval, it just means you're going to give all the possible angles at work to get this. You don't have to worry about tacking anything on in the end. So we're going to find all solutions of 2 minus sine squared x equals 2 cosine squared of x over 2. So basically this means we're going to find all the solutions, but we got to get rid of that half angle. So we just use the half angle formula for cosine of x over 2 and resubstitute back in. So the cosine of x over 2 is that. So I'm going to take this piece here and substitute this by doing that. Okay. It's just a large substitution problem. So we get 2 minus sine squared x is 2 times the quantity I just took the cosine of x over 2 and wrote it out as what the formula says a half angle is. Okay. Now, when I square that, it takes away the root and it also takes away the plus minus. Because what's a negative times a negative? Okay. So it gets rid of that as well. So you wind up with this. 2 minus sine squared x equals 2 times the quantity 1 plus cosine x over 2. Now what drops? The 2's drop. The 2's then drop. And you get 2 minus sine squared is 1 plus cosine of x. Now you're at, again, the point where you're going to use the Pythagorean identity, because you can't solve sine squares and cosines at the same time. Sine squared was, in terms of cosines, 1 minus cosine squared. So I substituted for that. Using a Pythagorean identity. You see that Pythagorean identity a lot in this section. Distribute your negatives then. Set aside equal to 0. So I'm going to 2 minus 1 is 0. So I get cosine squared minus cosine. What do they have in common? Factor it out. And now you have your two terms set equal to 0. It is a big pain in the butt problem. It takes a little bit of time to get through. So where is cosine equal to 0 and where is cosine equal to 1? Within one revolution, cosine is equal to 0 at pi over 2, 3 pi over 2. Good. And where is cosine equal to 1? Careful, is just 0. Because I'm in the bracket, and between the bracket of 0 and the soft bracket of 2 pi, so it means I'm going to include 0 but not include 2 pi. Those are my three answers. just, it's a lot of substitution, it's a lot of using many things that we've already done, it's just in a larger problem, that's all. Okay? I don't think that there's gonna be a lot of craziness for what you guys have for the weekend here. It should be relatively straightforward. I think there's only, what, 8 of them, but I believe there's only like 2 of them like this, if that. I don't think there's that
We
many.
only have these
35, so we're 35, 37. I don't even think, actually, I don't think we even get to this one yet. No, you don't even get to one like this yet until next week. So if you want to skip to where it's, if you want to try one, what number is it?
No, it's okay. We can wait.
No, I'm not saying skip, I'm saying, oh no, I think there is one in here. Never mind. Give them a shot, give that first day a shot. You should be able to fly through those, that's what should happen.
Wait, what were the changes you made for you?
On the day 2 one, Caleb, what was it? Add 41 and 45, I think? Is that right? Yeah, add 41 and 45.
But day one's the same.
Day one's the same, yeah. 41 and 45, you gotta know how to do those 2 problems before you can do 47.